So we are having a root diameter of the gear. We have PCD. We have the outside diameter of the gear, sometimes referred as a blank diameter. So this line, there are two here, something like that. I'm not good at drawing. Try to see something. Yeah, there are tools like that. Those tools, they go around. So this one, it will be your addendum. Addendum, which is the same as module. So this one, it will be your dedendum. Dedendum, which is the same as 1.25 addendum or module. So this line is your PCD, pitch cycle diameter. And your PCD is equals to what? Module and teeth. PCD is equals to sorry?
M times T.
It's equals to M times T. It's a module times number of teeth. Module times number of teeth. We also have something called circular pitch. This one is a pitch cycle diameter. We also have circular pitch. Circular pitch is the distance between the center of the teeth to the next center of the teeth, or from the edge of the teeth to the across to the other edge of the teeth. That is the circular pitch. We have PCD, pitch cycle diameter, which is from diameter is from there across to the center to there. That is your PCD. Then we also have a circular pitch, which is the distance between the teeth. So, gears, it needs to match with the other gear. It needs to match with the other gear. So, with the other gear, for them to mesh, the PCD for the other gear, it must be in line, or it must be in contact with the PCD of the other gear. There is the PCD of our second gear. Then this is the root diameter of the second gear. And this one is the outside diameter of the second gear. So here we have a tooth. So these lines, they represent the tooth. So okay, in this case, can you see here? There must be a space there, which is called a clearance. If this gear it goes, touches this point, the teeth, it won't mesh proper, or it can even cause a lot of damage. So you need this space the teeth it shouldn't penetrate up until it touches the root diameter of the other gear. So that's the clarity, ne? Yes. So for these two to mesh, this addendum there, it must be the same as the addendum for the other gear. This addendum for this gear, it must be the same as addendum for this gear. Because if they are not the same, if this addendum is bigger than for this addendum, it means this gear is going to touch there, meaning it's going to push there. Which it will result on where a lot of things will happen. Even the shaft can also bend. Lot can happen. So for these two to able to mesh together, the addendum must be the same. Okay, this is the set. When the two gears mesh together, what do we know about it? What is it that we know? Sorry? They transmit power, yes. Yes, they are there to transmit power. Even if they are not meshing together, they still transmit power. Because they can be connected on the same shaft, but we're still getting there. When they mesh together, what we know, I already said, addendum for this gear, if this gear 1, this gear 2 is the same as addendum for gear 2. We already know this. We know this one by now, ne? Yes. And we know that addendum is the same as module. Meaning the module for this one is the same as module for this gear. Module for this one is the same as module for this gear. Meaning, if you are calculating PCB, just example, and we are using a module. Therefore, once you are given the module for this one, it means that module you can use also for this one because the two are meshing together. When I say they are meshing together, it means this gear is driving this, or this is driving this one. Their teeth are in contact. You understand, eh? Yes. So, we have a rotational speed and a linear speed. I want to know from you, between this gear, when it rotates, it will rotate to this other side, this one will rotate to the opposite side. Because this teeth, it will be pushing, this teeth, it pushes the teeth of this other one on the opposite direction. Meaning these two, they won't be rotating on the same direction. So rotational speed. This one, as you can see by its shape, is bigger than this one. So I want to know, between this bigger one, number 1, and the number 2, the smaller one, which one will rotate faster? The smaller one will rotate faster, ne? Do you all understand that one? Yes, the smaller one will rotate faster. That was rotation. So let us now look at the linear speed. Rotation is M. Linear speed is V. Rev per second, meter per second. Radius per second, meter per second. So okay, between gear number 1 and gear number 2, which one it will move faster? Sorry? Number 2. Yeah, are you saying number 2 it will move faster, not rotate, move faster than gear number 1? Or gear number 1 it will move faster? They will move at the same speed. Who said that? You are right. They will move at the same speed. Now we are no longer looking at the rotation. We check how many meters does each cover within certain period. For this one to cover a same distance as this one, it means this one is going to rotate faster. Just for example, outside we have a tractor, eh? The back wheel is big and the front one is small. So are you saying when someone is taking that tractor to mall, the one at front, it will get to the mall later. They will get to the mall at the same time. Eh? Yes, they were no longer looking at how does it rotate. We check on the meters which it has covered. They are going to cover the same meters. This one, because it's rotating less, this one it will rotate faster so that it can cover the same distance covered by this one. Meaning velocity for one, it must be the same, is the same as velocity for two. As long as these two dimensions together, the velocity is the same. So meaning now, when the two gears are meshing together, we know module is the same, velocity is the same, but speed, the bigger one rotates more than, no, the smaller one rotates more than the bigger one. So okay, now let us check if we can find the ratios. We said V1 is equals to V2. And this velocity, the formula for velocity is V is pi times PCD, ne? PCD, I believe the velocity is pi d times n. In this case, we will be using PCD to calculate the velocity for this gear. To calculate the velocity for this gear, we use this diameter. Remember, I having 1, 2, 3 diameters. We do not use any diameter, we only use PCD as our diameter there. Ne? So times n for gear 1 over 60 is equals to pi PCD 2 times n2 over 60. Mathematics, 60 and 60 they are out. Ne? Pi and pi they are out. Ne? So meaning we have PCD1 times n1, which is the same as PCD2 times n2. So okay, before I carry on with this one, let us first substitute. PCD is empty, module times. So here we can say is module 1 times T1 times N1 is equals to module 2 times T2 times N2. Module 1 and module 1, they cancel because they're the same. Eh? So can you see? Now you are left with this ratio. This is the ratio T1, T2, 8. T1, N1, T2, N2. So the question is, you can be given a speed ratio. They say your speed ratio is 1. Your speed ratio is equals to 1 is to 2. Do you understand this? Speed ratio. We said this is a ratio. And also this is a ratio. So you are given this ratio as like that. How do you use it together with that one? Firstly, what you need to know is this speed ratio is the same as 1 over 2. So coming to this side, using that 1 over 2, you cannot say T1 N1 is equals to 1 over 2. This is wrong. That's a ratio. It does not have SI unit. So this one already we have SI unit for that one. So okay, what do? You cross multiply, you group them together. The number of teeth, the speed. Meaning you'll be having T1 over T2 is equals to N2 over N1. You understand that one? Eh? Meaning T1 over T2 is equals to, you can use it as your speed ratio. Or you can also say N2 over N1 is equals to your speed ratio. You understand? Eh? So now you are given this speed ratio. How do you then substitute your speed ratio there? Can I say T1 over T2 is equals to 1 over 2? Is this correct? Can I say N2 over N1 is equals to 1 over 2? Is that correct?
Yes.
But remember, on this speed ratio, I can also write it in this manner. I can still say N1 over N2 is equals to T2 over T1. Do you understand this one? Eh? Yes. So I can still write it in this manner. If you are saying yes, so I'm saying we can also say T2 over T1 is the same as 1 over 2. So, what you need to know is, before you use your speed ratio, you must check your gears. 1 over 2. 1 is greater than 2. Ne? So it means on top here, you must put, is the number of teeth, the less number of teeth. At the bottom, you must put the more number of teeth because the denominator this side is bigger than the one on top. You understand? Eh? So, which one it has more number of teeth here? The big one, which is gear 1, eh? And this one, small, eh? Which is 2. Is T2. So, is this ratio correct or incorrect? Incorrect, ne? Yes, this one is incorrect because at the top, as we're having a small number, we must also have the gear with a small number of teeth. Therefore, the one small number of teeth is T2, meaning that gear ratio, we must use this as... Okay. So it means this one is the correct one, eh? Yes. So this one is out. So all the time we must check. So okay, in terms of the speed, if I want to write the speed, 1 is to 2, N1 over N what? Sorry? N1 over N2. So N1 rotates slower than N2. N1 rotates slower. Then N2 rotates faster. In that case, this ratio you can use it as like this one. So sometimes they will say, what we call this one, your velocity ratio is equal to 2 is to 1. This one is the same as 2 over 1, right? So in this case, which end goes on top, which end goes at the bottom? And to here, and here, and 1. Those are for the gears which mesh together. So okay, even though this one is red, can you see? This one, if you check this one, is PCD. I guess you've already seen this. This one, I can say PCD1 over PCD2 is equals to N2 over N1. Is that correct? Sorry? I did it from this one. Remember, this formula is from this one. So I'm just taking it from here, then I divided everything by PCD, by cross multiple. You understand? Mathematics. That is why Mechanotechnics is teaching you mathematics. So that when you come here, yes. We already said this is a gear ratio. Can you see that one? This one is a gear ratio. Meaning, this one is already equals to what? A gear ratio. Not gear, a speed ratio. This is also, you can also use it with a speed ratio because it's equals to a speed ratio. You understand that one? So meaning, to take this one to a speed ratio, if it's this one, if your speed ratio is 1:2, which PCD you will use as your, which PCD are you going to use here as your numerator? For which gear? For gear 2, and this one for gear 1, eh? Because gear 1 is bigger, gear 2 is smaller. You use it like that. Okay, let me take this off. You don't need to copy these things in your book. So, okay. How long from there? This is the center of the bigger gear. This is the center of the smaller gear. How long from here up until there? That it will be a certain distance. How long? Okay, from here to here. I mean, this will say it's a PCD. It's a diameter, right? So from there to there, is it not half? Is it not half of it? It's a radius, right? So meaning radius. For you to find the radius, you take a PCD. You take a diameter and divide it by 2. So our center, it will be PCD. For gear number 1, you divide it by 2. Then you also add, is from here to there. You see? And also from there to there, which is a PCD for the smaller one, over 2, which is plus PCD of gear number 2 divided by 2. Which this one is the same as PCD for gear number 1 plus PCD for gear number 2. And this one we already said is M1 T1, right? Yes. Plus M2 T2 over 2. Which this one and this one, didn't we say it's the same because they're meshing together? Yes. So therefore, we can take a common T1 plus T2 over 2, which you can even write it in this manner. That is your center distance. This is the formula for your center distance. You are going to calculate this formula like that for your center distance. There's no need for you to drive, but it is important for you to understand. For instance, if you are having the diameters to get the center distance, you can just add the 2 and divide it by 2 to get the center distance. Any question? No question. Those were simple gears. So now let us go for compound gears. So now I'm going to draw these gears. I'm going to draw when I view from this side. When I view from this side, it means I will see this bigger gear, and I will also see this smaller gear. Here I have a shaft. Even there I have a shaft, which is connected on the center there. So, but instead of putting them in horizontal, I'm going to put them vertical. Here they are. This is my gear number 1. That is the shaft. Gear number 2. This is the shaft. What is it that you must always remember about gear number 1 and 2? They are meshing together. What is it that you must always remember? Sorry? M1 is equals to M2, ne? And what else? Sorry? V1 is equals to V2, right? Yes. Always you must remember that. So, you said, if we're having these 2 gears, this one, here we're having a motor. We're having a motor there. Do you know what's a motor? Which motor do you know? Which one? Electric motor. Do you know that even the engine is a motor? Yes, so here we connect the motor. Here we connect, yeah, it goes to the wheels this side. Goes to the wheels. So, okay, now we have the wheels here, somewhere this side is connected. Now we start the motor. The motor is going to rotate in one speed or a constant speed. So we assume that it's going to rotate in one speed. So as it rotates in one speed, gear number 1 and gear number 2. Between gear number 1 and gear number 2, which one is going to rotate faster? Sorry? Gear number 1 is going to rotate faster than gear number 2, ne? Yeah. So gear number 1 is rotating because this one is rotating. They are connected together by the shaft. Meaning gear number 1 is going to rotate at the speed of the motor. You understand me? So gear number 1 is going to drive gear number 2. You understand me? So gear number 2 is connected to the wheels. So as gear number 2 is connected to the wheels, let us check now. Is this car going to run or going to move slowly? Sorry? It's going to run or it will move slowly? It's going to move slowly, ne? Are we saying this gear, the big gear, is going to move slowly, and this one is going to move faster? Okay, now let us change our gear. Here we place the larger gear. Here we place the larger gear, and here we place the smaller gear. So now, between gear number 1, which is connected to the motor, and gear number 2, which is connected to the wheels, which gear is going to rotate faster? Gear number 2 is going to rotate faster, ne? So meaning now our car will run faster, ne? Because the wheels are rotating faster, right? You understand? So that is the reason we need a compound gear. Because you cannot always, when you want to run, you go down there to exchange those gears and make them bigger, make them smaller, so that your car can be able to run. So what do they do then? Then they go. Okay, they said, okay, here, let us put a little bit bigger gear. little bit bigger gear. So here they put the smaller gear. There's a shaft there. Here maybe there's this another gear which ends somewhere there. Here there's that gear. So now they put, now the wheels of this car is somewhere here. Here there are the wheels. So this rotate fast, this slow one, this rotate fast. What about this one? Is this one not rotating at the speed of this one? They are rotating at the same speed, because they are connected to the same shaft. If this return one revolution, even this one can turn one revolution, because they are connected to the same shaft. Do you all get that one? Yes. So this one and this one, they rotate on the same speed. Remember, this one is already rotating fast. Even this one is rotating fast. So this one is rotating faster. It means the small one is going to rotate more faster because this one is fast. And remember, the small one is more faster than the bigger one. So already this one is rotating faster because this is rotating faster. They are connected on the same gear. Therefore, this one will rotate more faster than this one. Therefore, your car can run faster. And this one is driving this one, they are meshing together there. This one is moving because they are connected on the same shaft. So this one will drive this one. Can you see? So your car is rotating faster. Now you need to, you don't want a faster speed now. What you do, there's a lever here. It goes outside. Then there's a fulcrum somewhere there. You are inside your car. You push this one to that direction. There's a swing, fulcrum. So it will push this gear towards this side. As it's going this side, this gear, it will come and stand somewhere there. And this gear, these two gears now, they will mesh together. Can you see that one? So this one, now, even this one is rotating because of this one, right? So this one is a smaller one, meaning it's rotating fast. Then now it's driving the bigger one. So now the bigger one, it will rotate smaller. Therefore, the wheels here, they're gonna reduce the speed comparatively when these two, they were meshing. You understand that one? So that is the basics. But we are not there. You and I, we are here. You and I, we are here. You have this gear, which is driving this gear, which is driving that gear. This gear is connected to the same shaft as this gear, and this gear is connected to that gear. We have this gear again connected to this gear. So this one is the shaft. Those are the shaft. So here there is an output. For output, you can put the generator, you can put the wheels, whatever you want to put at the output. Ne? Here is where there's your load. Here is where there's input. So I have gear 1, 2, 3, 4, 5, 6, 7. So with these 7 gears, it does not matter how you place them. The way I place them, it means if I were to close them inside, I will need a bigger box. So if you need a smaller box, you can take this shaft and you put it on the other side. So okay, That's not a big problem. Let us check here. Gear 1, this is 3, this is 4, 5, 6, 7, and 8. Gear 1 and gear 2. What do we know about gear 1 and gear 2? Same speed, same module. Eh? Gear 3 and gear 4, same speed, same module, because they are meshing together. Even only 6 and 7 is the same. 8 and 9, 8, 7 and this 2 is the same. This 2, the same thing. Velocity and module is equal. So what about gear 2 and 3? Which speed? Same rotational speed. Ne? Is velocity for this and this the same? They are not the same. Ne? It's only rotational speed. Only rotational speed for this and this is the same. Meaning, if you can calculate the rotational speed for this one, you already have the rotational speed for that one. Because they are the same, they are connected on the same shaft. Once you have the rotational speed for this one, you can calculate the rotational speed for this one depending on the gear ratio. Then once you have the rotational speed for this, it's the same as that one. Then you calculate the rotational speed of this one using the information for this two. Then when we have the rotational speed for this is the same as this one. Then you calculate the rotational speed of this one using this gear and the gear ratio. Now we have the speed for this one. Once you have the speed for this one, you have the speed on your load. For instance, you can say T1 N1 is equals to T2 N2. And there will be every number of T. This N1, you'll find that from the motor, right? Now you substitute the number of T. Don't you have N2? You can be able to get N2, ne? And we say N2 is equals to N3. And that's because these two dimensions together, it means T1 and not T1, T3 N3 is equals to T4 N4. And this one, is it not that one? It is, ne? So now we can be able to calculate N4. So from there, we know that N4 is equals to N5. Not N4, which you are doing. The speed, that one. You understand me? It goes like that up until to the end, depending on what is it that you need to calculate. Sometimes you will be given the speed, sometimes you will be given you will need to calculate the speed. And you can even come from this side. If you know the speed of your load, if you know the speed of your load, it means you know the speed for N8. Therefore, T8 N8 is equals to T7 N7. You already know. If you already know the load, you can calculate backwards up until number 1. Sometimes you may find that you need to calculate the speed on this one from backwards. You can do it like that one. Okay. Sometimes you are given the input speed. What they want is an output speed. I want to calculate the speed for this one, the speed for this one, the speed for this one, the speed for this one. That it also takes time. Eh? but that doesn't mean you won't get the answer. It also takes time. But there's also a formula whereby an input speed, let me take this off, whereby input speed N in over N out is equal to the product of a driven teeth. Over product of driving or drive. So this one is when you want to calculate your output from input straightforward without checking on the gears, each and every gear. So when we talk about which one is our input speed, which gear? It's N1, eh? Yes, N1 over, which one is this one?
N2.
Sorry? N8. So that one, what will be our, this one is the product of driven. Between gear 1 and gear 2, which one is the driven gear? Gear 2. Gear 2 is being driven by which gear? Gear 1. Eh? So now let us write a driven gear, which will be T2 times. Do you have any other driven gear? T4.
Yes.
T4. Why is it that is driving T4? It's T3, eh? So T3, what is it that is driving T3? T2 is not driving T3. T3 is moving together with T2. Although they are connected to the same shaft. That is why they are moving together. So this one drives this one. Yeah, so this one is a driven. This one is a drive. So do we have any other driven? Is T1? T6 times? T8 over T1 times? T3 times? T5 times? T7. You can also do that one. Check. Okay, thanks.